Okay, what can we say about this? Obviously, it has four sides. All kites are quadrilaterals. So the first one, these two diagonals, do they look perpendicular? If you would build a kite, you want to make those perpendicular, right? So that is yes. Those are perpendicular. Okay. Then, QP and QR, if you were building a kite, would you make those the same length? Yep. So these two are congruent. Are SP and SR congruent? Yep. Okay, so the definition of a kite is this. It is a quadrilateral, which means it has four sides, where two sets of consecutive sides are congruent, but opposite sides are not congruent. Okay? Two sets of consecutive sides are congruent, but opposite sides are not congruent, and that makes up a kite. Okay? What happens in a kite is that the diagonals are perpendicular to each other. Does PR bisect QS? And the answer is no. Does QS bisect PR? Does QS hit the middle of PR? Yes. This one's a yes. The other one, does PR hit the middle of QS? No, it's not going to be at the middle. Okay? It's never going to hit at the middle of that. It's going to be to one side or the other. So, PR bisects QS is a no. QS bisects PR. That's a yes. Is PQR an equilateral triangle? In some instances, it could be, but does it have to be? No. Is PSR an isosceles triangle? Yes. Is PQR an isosceles triangle? Yeah. PQR has two sides congruent. That's isosceles. This triangle here is isosceles. Okay? So the isosceles triangle theorem works here. So this angle is congruent to this angle. This angle is congruent to this angle, which then from there you can say various other things because these are 90 degrees. And then, so if these are congruent, then that makes these congruent to this. And this one here congruent to this one here. And various things. Okay? So, how are the diagonals of a kite related? What's one thing we learned up above about diagonals of a kite? They are always the diagonals. The diagonals are what to each other? Perpendicular. Perpendicular. They form a right angle. Also, which one bisects the other one? In this case, does AC bisect DB or does DB bisect AC? The second one. DB bisects AC. Okay? And then the diagonals are perpendicular. So, diagonals are perpendicular. And so now let's figure out angles. What's angle 1 here? What's angle 1 going to be? Have to be 90 degrees. Because these are right angles. Okay? So, isosceles triangle theorem for this triangle. This angle is going to be congruent to this angle. So angle 3 is going to be what? 35. Okay? If this is 90 and this is 35, what does angle 2 become? 90 plus 35 is 125, right? 180 minus 125, because this is a triangle here. 180 minus 125 is 55. So we could figure out every single angle here if we wanted to. Okay. Well, we might need one more angle over here somewhere to figure out all these. So if this is like 20 degrees, then this would be 20. And since this is 90, this would be 70, and this would be 70. See how easy that is? Once you figure out one, then you can get a whole bunch of them. Okay? All right. The other thing we're going to talk about is trapezoids. What is a trapezoid? A trapezoid is a quadrilateral with one pair of opposite sides parallel. The other pair of opposite sides are not parallel. It only has one pair of opposite sides parallel. Okay? The parallel sides are called bases. The non-parallel sides are called legs. Okay? If you have an isosceles trapezoid, then the legs are going to be congruent, which makes the base angles congruent and the other pair of base angles congruent. What do we notice about the non-congruent angles? What do you notice about the non-congruent angles? What do they add up to? 180. Why is that? Well, these are parallel sides. And if you remember back to chapter 3, maybe it's chapter 2, I forget which chapter it is. These two angles are in between parallel lines. They're same side interior angles. What do we know about same side interior angles? They are supplementary. Okay? All right. Another thing about isosceles trapezoids is the diagonals are going to be congruent to each other. Are they going to bisect each other? Do they split each other in half? No, they don't split each other in half, but they are equal in length. They're equal in length. So if AC is 12, then BD is how long? 12. Okay? All right. So, looking at this trapezoid, this is a big power line pole. You see some of these around South Dakota, different places. Up by Clark, out by Pierre, there's a bunch of these. Okay. So, if this is 10 and this is 10, it makes it an isosceles trapezoid because these two beams are going to be parallel to each other. Okay? So, if angle 1 is 138, that makes this 138. Then how big is angle 2 down here? Well, what do we know about these two angles? They add up to 180. So this is 42. Okay. Okay. BD. BD is a what of the trapezoid? What do you call that thing? You call it something not a cross. It's a what of the, not the median. We'll get to that here pretty soon. It's a diagonal. It's a diagonal. BD and AC are congruent to each other. They're both diagonals. And what do we know about diagonals of isosceles trapezoids? They are congruent. So x plus 3 equals 3x minus 11. So if we subtract x, 3 equals 2x minus 11. If we add 11, 14 equals 2x and divide by 2. X equals 7. We stick 7 in there. BD equals 10. AC, if we stick 7 in there, is 21 minus 11, which is 10. They better be the same, or else you did something wrong. Okay? Those are the lengths of the diagonals. Now, we're talking about a median. We don't call this a median in a trapezoid. We call this thing a mid-segment. A mid-segment connects the midpoints of the two legs of a trapezoid. A mid-segment is going to be the average length of the two bases. How do you find an average? Well, you add them up and divide it by the number of numbers. Well, how many bases do we have? 2. So we add them up, divide by 2, or take 1/2 of these. So you take 10 plus 4.2, add them up, and divide by 2. So 14.2 divided by 2 is 7.1, which is the length of this midsegment. So if you wanted to figure out the length of this midsegment right here, knowing this base is 6 and this base is 9, what do you do with the 6 and the 9? Add them up, divide by 2, and 7.5. Okay, 7.5. All right. How long is this fence? So the dogs are in kind of an odd-shaped yard, okay, where these are 60 and 60, so this is the midpoint of this side. This is 65 and 65, so this is the midpoint of this side. So the mid segment connects the midpoints. You take the two bases and you do what with it? Add them up and divide by 2. 190 divided by 2 is 95. It'll take 95 feet of fencing to section that off. Okay? So that's what we did today is kites and trapezoids. Kites and trapezoids. So that is it for today. So you're going to have 50 minutes to work on like 11 problems or however many problems that is. Okay? So you will have plenty of time to work on it. The problems, some of them are a little more difficult. So do your best. If you have questions, ask.